Welcome to part 2 for Topaz Image Enhancement Program benchmark on the M1 Pro and M1 Max. For this part, I'll be focusing on RAW files directly from the camera and also a Panorama DNG from Lightroom. Let's find out how these programs perform on these new computers. This is Artist Right. Before we start, subscribe if you're new and hit on the bell icon so you'll be notified every time I upload cool new videos like this. Future Art with a quick update. After I released the first Topaz image test video that is based on JPEG workflow, testing it on the M1 Pro and M1 Max, I received a comment from SKSwani0419 which pointed out that I can go into all these program preferences and then choose the processor that I want to use so that it is better optimized. And once I choose the processor, I can decide how much memory I want the program to go in and utilize, to which I have the option for high, medium, and low. So I've gone in and choose the option for the M1 processor and high memory usage. And after running all those tests again on a few selected machines on both the JPEG workflow that you can watch in part 1 up here, and also what you're about to see in the RAW workflow, starting out with the JPEG workflow. With DeNoise AI and Sharpen AI, sometimes I may see about a second's improvement when I'm working with those JPEG files, but most of the time they are pretty much exactly the same on the machine I've tested, the 16, 32, and 64 gigabytes of RAM on the system and across multiple different Apple M1 Pro and M1 Max SoC. The only program that I've seen some improvement is on the M1 Max with 64 gigabytes. When I use those two JPEG files that I use in part 1, I'm seeing about 13 to 14 seconds time improvement, which is a good amount of time that has been improved, but it doesn't really change the overall equation much. As far as testing the 32 and also the 16 gigabyte machine, the time is pretty much the same. And when I throw in these RAW files that you're about to see in this video and ran the test using the M1 SoC and also the high memory usage, pretty much the results are exactly the same across the machine that I have tested, so I have confirmed the result already. And the magic number that I'm going to share with you in this video, and I also have shared with you in the past video about the 75% memory usage, that still pretty much applies even though I've gone in and choose high on the system. So what this is telling us is that Topaz software is still not fully optimized for the M1 Pro and M1 Max processor, and I would go as far as saying not even the M1 or the Intel machines based on the result that we're seeing so far. It works, and brute force tends to really perform really well because these are really amazing SoC, but the memory usage, I like to see more of that. I also like to see the program go in and utilize much more of the CPU and GPU resources on the system. But anyway, I'm going to return you back to part 2 of the Topaz test so you continue and see the results. This will be information rich with a lot of analysis. To leave timestamp in the description below. Feel free to pause the result too so you can analyze them yourself a little bit longer. Let's take a look at the test and reference system that I'll use in this video. There's only going to be 4 of them. I am simplifying this down from part 1 if you have viewed that. So for this, I have 2 M1 Max, 2 M1 Pros. And with those, I have memory that goes from 16 to 32 to 64, so we'll be able to see how the memory affects the performance and if the result is the same when we use RAW versus when we use a JPEG file. As I mentioned already in part 1, I've gone in and tested DeNoise AI, Sharpen AI, Giga AI, so all those 3 programs got tested with a JPEG file. For this part, I am testing DeNoise AI and just Giga AI and using these programs in succession of each other with the same exact file. And this is a little bit different than part 1 where I just put in those images individually, have it run the analysis as an independent file and start fresh every time. For this one, what I am going to do is run the file through DeNoise AI and then have it go through the Giga AI right afterwards. So we're using the file that has already been processed through Topaz once and going through the program again. Part 3 is coming up soon, so make sure you stay tuned to the channel for that. That will be talking about video enhanced AI and just specifically about that. I already talked to you a little bit about the workflow, and what we're going to do is take these images. For example, this will be the control group images that I will use. This is a nighttime shot in Hawaii, and this will be the first normal file that I'm going to use. This is a D810 36 megapixel, and this will be an NEF file, 48.1 megabytes that just pretty much comes directly from camera. There is no edit, there's no sidecar file, nothing, just directly from the camera, from my archive, and we're going to throw this in right away. The other one is a panorama file. This is a 50.8 megapixel panorama that is stitched together from Nikon D810 file. This is a DNG file that is 184.1 megabytes. We'll see how the program does perform. And on the very last one, I am throwing back in the 192 megapixel panorama that is a DNG file at 687.9 megabytes, and we'll see how these program runs. As I mentioned in my previous video too, that none of these software are fully optimized for the M1 Pro and M1 Max and all the other machines, but predominantly they're not optimized for these generation computer yet. So right now we're just using brute force to approach all these, and the processor is doing a really great job with these brute force approach. Before we look at the result, let's see how DeNoise and Giga AI is utilizing the system resources available to it. Starting out with the CPU usage, pretty much these are in succession of each other, meaning that once I have run the file through DeNoise AI, I quit the program and take those exact files that DeNoise AI produced, put them into Giga AI right away. On the 16 gigabyte model with 16 GPU, we can see that the GPU is being utilized fairly heavily. However, on the 32 gigabyte model with 32 GPU, you can see that is barely just peaking on top there. This means that if Topaz really want to go in and optimize their software to take advantage of this 32 GPU, there is a lot more room. In fact, close to around 75% of it most of the time, whereas it's already utilizing the max amount of GPU on the 16 one. But when you have double that and it's really dropping down that much, it just tells us that this is not fully efficient just yet. As far as GPU memory usage go, you can see the spread there. I mean, this doesn't really give us much indicator because it's showing this to us in percentage. But if we take a look at the memory pressure, the actual memory, and the swap on the 16, 32, and 64 gigabyte model, we're starting to see a picture that is being painted. So, starting out with the pressure, if you have 16 gigabytes, most of the time when you're running a software, it's already peaking at above 50%, between 50 and 75. This is a good indicator. You're probably going to need more memory in your system, especially if you're constantly running at these kind of peaks above the 50% and getting close to that 75% threshold. For the 32 gigabyte, the peaks are there, but it's not quite as much. There's only a few peaks, so it's not quite as dense and not quite as consistent. And on the 64 gigabyte, it's only just one peak. When we're probably pushing together or making that panorama much larger, that would probably be the only thing. What I'm also finding interesting about the actual memory usage too is that if you watch part 1, there's a magic number, and that is 75% of memory usage. Well, this is being repeated here. You will notice that no Topaz software goes above 75%, at least on the M1 Pros and M1 Max computer. And I find that very interesting because I like you to utilize more memory. I like you to go in and use it all the way because you're really doing this in bursts. Why not do it so you get much faster performance? Yes, I understand the system still needs memory, but come on, I think you can do much more than that. And we get a lot more compression. That's the one in purple on the 16, a little bit less on the 32. Whereas on the 64, we're getting that little compression there that's happening at the end, and that's when we're merging the panorama files. But it's not really doing that much compression, not doing that much swap into the system at all. The swap number, though, are really going to tell you how the system is performing, and the swap is quite a big deal on the 1632 versus 64. So on the 16 gigabyte model memory, we have a swap that's going up to 33.9 gigabyte. That is close to 34 gigabytes. On the 32 gigabyte model, the swap is going up to around 28. However, on the 64 gigabyte model, because we're now really pushing the program that much harder with these panorama RAW, we're really using around 1.4 gigabyte, which is actually not bad at all. That's kind of the numbers I would be expecting, but that also goes back and correlate into the actual memory usage. You can see this purple correlates to the memory swap. So the moment it starts to create that compression memory, and if anything gets close to that 75% range, it starts to write to the SSD. Kind of a very interesting behavior. Let's have a look at the result from DeNoise AI, starting with the NEF file. This is the 36 megapixel directly from camera, pulled from my archive. And for the most part, these are only a second apart. I mean, this is within margin of error. In fact, the 64 gigabyte model take 1 second longer than the other one. But when it comes to these single digit lower performance number, we're really talking about milliseconds apart and the way how it's being rounded up. So I probably wouldn't worry about it. So this is not really giving us any good indicator about how these machines perform at all whatsoever. If we take a look at the medium panorama file, this is a DNG file stitched together in Lightroom. The file size is 184.1 megabytes. And if we take a look at this together, we can see that there is a 2 seconds slower or 2 seconds faster on the other machine comparing between the 64 and the 32. Yeah, not that big of a deal. It's still within margin of error, but this is starting to indicate that having less memory in the system will definitely increase the time that the program needs to do everything. And when we look at the large 192 megapixel panorama, the DNG file that comes out to 687.9 megapixel, we are definitely starting to see a difference. So on this test, 64 gigabytes of memory is showing a clear sign that it is doing that much better. However, when we really consider between these two computer configuration and the fact that it's using both the max GPU or the max SoC, between that 64 and 32 gigabyte model of memory, you're looking at $400 difference for a 13 seconds improved performance. For me, I would probably say that if you don't really need 64, I wouldn't even jump up to 64 gigabyte because it doesn't make a lot of sense and the improvement is really marginal compared to the rest. And when we take a look at the spread for the other 32 gigabyte model, they're in 2 seconds of each other. And if you really compare this relatively, I mean, just the base 16 Pro with 16 gigabytes memory is only 10 seconds longer than the 32 gigabyte memory one. So some of you will probably look at this and say, well, if it's only 10 seconds longer, this one I'm saving $800 compared to the top machine. It may be even more worth it. And I would say you're probably right. However, I would say that if you do any type of multitasking and you use photo software, which are generally more RAM hungry, I would just upgrade to 32 because it is a marginal gain now. It costs $400, but you're going to see that improvement come when you use the other program, when you have multiple programs opening at the same time. So now let's have a look at Giga AI result. On Giga AI, with the NEF base 36 megapixel file that is 48.1 megabytes, we're starting to see a difference, and this is huge. So having more RAM does increase the performance, but is this enough? A $400 difference to go from 52 seconds and really go to like 1 minute and 9 seconds. You're gaining about maybe like 18, 17 seconds faster or so. I don't know. This is something that you have to answer yourself. But for me, if I didn't need 64, I probably will not get the 64 gigabyte machine. But I'm crazy and I run a lot of apps at the very same time. I leave Safari tab open. I use multiple programs. So 64 fits me well, but 64 for you may be a question that you probably want to ask yourself and see how your workflow is and what your kind of personal computing habits are. Going between these two 32 gigabytes model, I mean, the Max and the Pro, we're seeing like 4 seconds difference. This can be account to the fact that the Max memory is faster, but if you're going for the Max because of the faster memory for this 4 seconds, it's definitely not worth it. So I wouldn't even look at this and compare these two between memory speed. I would just look at it as a margin of error between different processes or different SoC, for example, the Max and the Pro. And we can see that if you have less memory in the system, this time definitely increased. So we're talking about double the amount of time. Between this to this is 800. Between this to this is 400 on the memory configuration. So you really need to decide what you want to do. But personally for me, I would definitely go for 32 gigabytes of memory because this represents a significant amount of time that you're going to save, especially if you go through all these files. And this is just one single 36 megapixel file. Let's now look at the Pano. On the Panorama, 184.1 megabyte. So this is a medium-sized Pano, and we're not really seeing too big of a difference between 64 and 32, which is very interesting. They were in like about a margin of error of each other, like 7 seconds. This is part of the reason why I say that in these Topaz programs, going beyond 32 doesn't really give you that much of a benefit beyond just minimizing the amount of swap that happens to the SSD. If you really look at between the 32 to 16 gigabytes, we're starting to see a significant difference. We're starting to see about a 30% improvement in speed and time that it can do something. So I definitely recommend getting 32 gigabytes. And let's do one more file. And this is going to be the super huge 192 megapixel DNG stitched together in Lightroom. The file is a 687.9 megabyte. And with this, between 64 and 32 is a sad 9 seconds faster. It's not that big of a deal. Personally, I would not spend that extra $400 to upgrade from 32 to 64 unless you definitely have a need for it. Between this though, the 32 and the 16, yeah, there is a much significant improvement in speed. So you're really cutting the time down by around like 25% just about to just get things done. I would definitely go for the 32 just based on seeing these results so far. So let's look back again at the GPU and the GPU memory usage. On the 16 gigabyte 16 GPU model, there is a huge use for GPU. On the 32, there's not that much. This tells us that there's room for improvement, but also that, I mean, it really doesn't matter once you really bump up the GPU. Would it help it go faster? Maybe, but we're not really seeing that significant difference whatsoever. If we take a look at the memory, as I mentioned before, the memory pressure are kind of about the same, but if you start to look at it closely though, the 16 gigabyte is really pushing into this range. And if you're constantly doing this type of workflow, this is a good indicator and is telling you that you probably need more real memory on the system, more actual memory. The actual memory reflects the same way. However, that 75% mark, as I told you earlier, is still there. I don't understand. It's probably some limitation, but we're seeing a lot more purple. That's the compression. Less so on the 32 and almost none at all on the 64 gigabyte. Not that it doesn't exist, it does, but for that very small slit at the very end when it can't really do any of those kind of processing. And if you take a look at the total amount of file being swapped on the system, 16 gigabyte, about 34 gigabytes being swapped. This is around 28 on the 32, and on the 64 is only 1.4 gigabytes. So the option's up to you. But here's the thing, if you get 16 gigabyte model, I would definitely go more than 512 SSD for sure, because if you fill that up and there's not a lot of room for swap on the SSD, your computer is going to run definitely much slower. So if you're going to go with lower memory, definitely configure it with more SSD space. That's why I always recommend that if you go out and configure your machine, 1 terabyte tends to be the perfect sweet spot for many of the pros out there. You can always configure more, but that's my general thoughts about this. So, coming down again to the SoC that you want to choose in the RAM, SoC doesn't really matter much. It doesn't really matter the processor you choose. The amount of RAM that you put on the system will make a difference, and I recommend going with 32. Personally, I recommend the base M1. Again, the 14-inch base M1 if you're on a budget and you just want to get the best performance possible, upgrade the memory to 32 gigabyte, 1 terabyte SSD, and you're set. So if you're a student, you're starting out, you're not really sure what machine to get, but you want a machine that holds value really well and is a good performer, this is definitely the one. So that's my recommendation here, but definitely go with 32 gigabytes of memory. As far as stretching to 64, you really need to look at your workflow and see what you do and see if you need that. And there's one more video coming, that is part 3. This will be the video enhanced AI from Topaz, and we'll talk a little bit more about the way how this program is utilizing the computer, the performance and everything, but it will be very interesting. Thanks so much for staying tuned to this program and watching part 2. I greatly appreciate it. If you have any questions or comments, leave them below. Give this a like, subscribe, and hit the bell when you. And remember, in art we trust.